Now we're going to be looking at our normal distribution. There's a few things that we talked about last week. Let me use this space right here. As a reminder, we talk about our mean. Remember when we added everything, we added all of our numbers and we divided by how many we had. We also talk about our variance. Remember when you got the mean, I gave you guys a list, you guys got the mean, and then you guys found the difference between each of those values minus the mean, and then square the values. And then you guys have to get the mean of the new list. And we also talk about what I called standard deviation. Standard deviation. Now for variance and standard deviation, it gave you Greek letters. For variance, I call this sigma squared, right? We talked about this last week, so you guys should remember variance was sigma squared. Now, standard deviation, I use the Greek letter sigma, right? You guys found the variance and got the square root of that. Now, for mean, we're also going to use a Greek letter. Let me introduce you to a new Greek letter. This one. It looks like a U, but the left side of the U is extended a little bit more. We're going to call that mu. That's the Greek letter mu, which is what we're going to call for mean. Okay, I'm going to use these values. Basically, I'm going to use the mean and standard deviation. I'm not going to quite use the variance. I wanted you guys to know how to get the variance, because for the standard deviation, we just get the square root of the variance. So let me cross out variance. I'm only going to use mean and standard deviation. Now, some of our questions, you're going to be given the values. The mean is, and they are numbered. The standard deviation is. Now, this is something we use a lot. This bar that you guys see here, this upside down parabola, is something we use a lot with statistics, right? Here in Algebra 2, we have the beginning of stats. The number in the center, that's what I'm going to use my Greek letter mu. So it is our mean. That's right in the center. Now, my first dotted line to the right of it, I'm going to say it is the mean plus 1 standard deviation. The second line is going to be the mean plus 2 standard deviation. And this last one, it's going to say it is the mean plus 3 standard deviation. Or I could extend it more, but I'm just going to leave it at 3 standard deviation. Now, to the left of the mean, I'm going to say this is the mean minus 1 standard deviation. Then I have the mean minus 2 standard deviation. And then we have the mean minus 3 standard deviation. Statisticians, right, people that look at stats, use these graphs a lot. As a matter of fact, math teachers, sometimes we use it. We want to see the stats on the test. How well did you guys do? Now, interesting part is that in between this section, so mean is in the center. Let me highlight this section. Now, this is a big section that we tend to look at, right? I combine those two sections, and I'm going to use a rule that we call the 68, 95, and 99.7 rule. Now, what do I mean with that? That yellow section that you guys see, the one that I highlighted yellow, 68% of our study is there. 68% of our people are there. So if I came and I gave a test and I want to see what's the average, what was the average score that all of you guys got, right? I find the standard deviation. So I'm going to find out what 68% of you got. So that section, that yellow section is 68%. So I'm going to say, let me break this thing down as this is 34% and this is 34%. right? 34 and 34 combined is 68. Now, in between this dotted line and this other dotted line, so this other, oh, not that section, from mean minus 2 standard deviation to this other bar. So some of you might be like, oh, you're talking about this whole section here. Yes, this whole section, there's going to be 95% of my people there. 95%. Okay, so I know that between the first two is 90, it's 68. So I'm just going to go 95 minus 68. 95 minus 68 is 27. I'm just trying to find out what values to put in these two sections, right? Because all four sections is 95, but I already have 68. So 95 minus 68 is 27. Now let me break my 27 in between those two sections. So I'm gonna say each of these has 13.5% of my people, right? If you add all four sections, you should add up to 95%. Again, I'm talking about percentages here. Now, between these sections, right, so now I'm covering more sections. If you notice, there's 6 sections that I have. Now, in between these 6 sections, I'm gonna say I have 99.7% of my people there. 99.7%. Okay, so let me find out the value that goes here and here. Okay, 99.7 minus 95 is 4.7. 4.7 divided by 2 is 2.35. So about 2.35% of my people are in between each of these sections. And I'm gonna say to the left of this line is 0.15. And then, I mean, to the right of that line, and then to the left of this other line is gonna be 0.15. So this is what we call the normal distribution. Normally this happens, right? We find the mean, we find the standard deviation, and we find the values where most people will be falling into and then out of each section. Now, I'm gonna ask you to use this information, this normal distribution graph here a lot. So I'm gonna look at the next two sections, the next two questions, I mean, how to use this graph. I'm gonna ask you between two values. So I could ask you to combine sections here. I could say how combine, for example, combine just these two sections. And I want to know what's the percentage of people that are there. But I could ask you just combine those two sections. So I will expect you to go 34 plus 13.5%, and then you guys will get your answers. 47.5% of my people will be there. Well, I could even ask you just a line. I could say, let me highlight a value here, and I can say how many people are to the left of it. So basically, I'm combining all of these sections. Right, I could ask you how many people are to the left of that. What's the percentage of people to the left of that or to the right of it? Okay, so let's make more sense. Let's take a look with an example here. So if the mean, right, that Greek letter mu, if the Greek is 60 and the standard deviation is 7, what percentage of values in the data set lying between 67 and 46? So I just said, Imagine I have a normal distribution here. My mean is going to be 60. My standard deviation is 7, right? So to the right of it is going to be 67th and then 74th, on and on. So notice how I added 7, right? The mean plus 1 standard deviation, the mean plus 2 standard deviation. Now to the left of it, I can go 53, right? 60 minus 7. Or I could go 46. Okay, so now look. I want to know what percentage lies in between 46 and 67. Using our table above, I know this is 34 and this is 34. And this one right here is 13.5. So just add everything. And I'm going to say 81.5. Oh, let me write better. So 81 point, this pen is writing bad, 81.5%. Right, I just added 13.5 plus 34 plus 34. Now here, question number 23. Suppose that weights of watermelons are normally distributed. If 68% of the weights are between 40 and 60, okay, so let me take a look at what I mean here. How am I doing this? 68% of my people. Let me do a normal distribution here. Right, my first dotted line there. I'm just looking at the two sections in the center. Isn't that 68%? So 68% of the weights are between 40 and 60. Okay, so this is 40 and this is 60. What is the best estimate in pounds for the mean and the standard deviation? All right, for the mean is basically what number is in between 40 and 60? All right, so probably can tell between 40 and 60 is, you guys already know. Now, if you don't know what numbers are between 40 and 60, add them both, 40 plus 60. So I'm just going to do it at the side. 40 plus 60, and then divided by 2. 40 plus 60 is 100. 100 divided by 2 is 50. Now, some of you are like, I already knew between 40 and 60, the number in the middle is 50. That is our mean. What's the mean? 50. So I can answer the mean. Now, what's the standard deviation? What's the difference between the mean and my first line right here? To either side. What's the difference? How many numbers did it go up or did it go down? From 50 to 60. Well, my standard deviation in this case happens to be 10. Okay, I want you guys to know how to use the normal distribution graph. So this example number 21, copy those examples, copy those percentages. You are going to need them. All right, any help? I'm just an email away.